We can see how the double angle identities are helpful when we have an expression of, say, the sine of nx, and we want to be able to reduce that where n is some integer. But it's also important for us to be able to reduce powers of sine, cosine, and tangent. And to do this, we're going to introduce the power reducing identities shown here. Let's prove the first one, sine squared of x is equal to 1 minus the cosine of 2x over 2. Using the double angle identities that we just looked at, we know that the cosine of 2x is equivalent to 1 minus 2 times the sine squared of x. If we divide and rearrange this, we can rewrite this as 2 sine squared of x is equal to 1 minus the cosine of 2x. So I just moved this here and moved this here. And then if I divide everything by 2, I get the identity here. Sine squared of x is equal to 1 minus the cosine of 2x over 2. These reductions come in handy when we're dealing with higher powers. Say, for example, we want to be able to express sine to the 5th of x in terms that only contain first powers of sine and cosine. Recognize, first of all, that we have to know our rules of exponents. So sine to the 5th of x becomes sine squared of x times sine squared of x times sine of x. So we've already reduced to one place where we just have a single power of x or of sine. And now we can rewrite these sine squareds as 1 minus the cosine of 2x over 2 times 1 minus the cosine of 2x over 2 using these power reducing identities that we just discussed. When I multiply these out, I now get 1 minus 2 cosine of 2x plus cosine squared of 2x all over 4 times the sine of x. And then when I multiply everything out here, I end up with 1/4 times the sine of x when I distribute the sine of x inside, minus 2 cosine of 2x sine of x plus cosine squared of 2x sine of x. As we then take this double angle identity, this can be rewritten as 1/4 sine of x minus 2 cosine of 2x sine of x plus 1 plus the cosine of 4x over 2 times the sine of x. We can then simplify that to 1/4 times the sine of x minus 2 cosine of 2x sine of x plus, when I distribute the sine of x, I get sine of x over 2 plus cosine of 4x sine of x over 2. And then when I combine like terms, specifically looking at my sines of x, I get 1/4 3/2 sine of x minus 2 cosine of 2x sine of x plus cosine of 4x sine of x over 2. So I've reduced this to only first powers of both sine and cosine, which is much easier to work with.